Your laptop carries two completely different addresses at the same time, and the internet would collapse if it tried to use just one. Here is why every device needs both, and how they hand off to each other at the last hop. Delivering data across the planet has two very different challenges. First, find the right network among hundreds of thousands, anywhere on Earth. Second, on that final network, deliver to the one exact physical device. A single address cannot do both jobs well, because one needs to be flexible and hierarchical, while the other needs to be fixed and unique. The IP address is a logical, hierarchical address used for routing between networks. It changes depending on where you connect. The MAC address is a flat, fixed hardware address burned into your network card by the manufacturer, used for delivery on the local link. They operate on different layers and solve different halves of the same problem. A MAC address is 48 bits, written as 6 hex pairs like 3C, 5A, B4:1F, 22:9D, where the first 3 bytes are the OUI identifying the manufacturer. MAC addresses are flat, meaning there is no geographic structure, so you cannot route the whole internet by MAC. There would be no way to summarize billions of them. An IP address is hierarchical, split by the subnet mask into a network part and a host part, which lets routers summarize huge ranges into a single routing entry. When you move from home Wi-Fi to a coffee shop, DHCP gives you a new IP that fits that network, but your MAC never changes. To send data off your network, your device sends the packet with the destination's IP inside a frame addressed to the router's MAC. To learn that router's MAC from its IP, the device uses ARP, broadcasting who has this IP and caching the reply. At each router along the path, the frame and both MAC addresses are stripped off and rebuilt for the next hop, while the IP packet keeps its source and destination IP. On the final network, the last router uses ARP to find the destination device's MAC and delivers the frame directly to it. Take your phone from home to an airport. At home it might be 192.168.1.30. At the airport it could be 10.55.12.8. A totally different IP chosen by that network's DHCP. But its MAC, set by Apple or Samsung at the factory, is identical in both places. You can prove the OUI link yourself. Look up the first 3 bytes of any device's MAC in a public OUI database, and it will name the manufacturer. The biggest misconception is that the MAC address travels end-to-end across the internet like the IP does. It does not. The MAC only matters on the current local link and is replaced at every router. Another mistake is thinking IP addresses are permanently tied to a device. They are assigned per network and change as you move. People also assume MAC addresses are perfectly unique forever, but modern phones randomize their MAC for privacy on each network, deliberately breaking that assumption. IP is the changeable, hierarchical address that routes data to the right network, while MAC is the fixed hardware address that delivers it to the exact device on the final link, and ARP is the bridge that connects the two. I explain one foundational idea that makes everything else click every single day. So subscribe to Tech with Joel. Look up your own device's MAC and tell me in the comments, which manufacturer do the first 3 bytes reveal? Subscribe to Tech with Joel.